So the next example we're going to look at is going to be another RxJava code case study. And this is going to demonstrate how to apply timeouts in the context of the RxJava framework. And this is also a pretty cool example. So what you can see here is we're going to be computing essentially the cost of flying, I believe, from London to New York, and we're going to get the results in British pounds. And we're going to do this a bunch of times and show off a bunch of cool features that motivate the need for timeouts. So we're going to have a thing called a default exchange rate, which we're going to say if we don't get a response from some kind of microservice that is an exchange rate service, we'll just use this result, and the default is 1. The exchange rate is 1-to-1 between pounds and dollars. That is unlikely, but that's what we put in here. And we also have a similar thing for Flowables. So we have singles and Flowables, and you'll see why we need Flowables, because we're going to show both a version that uses the kind of the RxJava subscribe on technique, and then we're also going to show another version that uses parallel Flowables. We're going to run the test 5 iterations for each of the different use cases for the different concurrency models. And we're going to have a random number generator to generate certain things randomly. The main program just runs the example, and here's the run method. And what we're going to do first is we're going to run a test that runs demonstrates timeouts using RxJava concurrent singles. And then we're going to demonstrate how to use timeouts for RxJava parallel Flowables. So let's go ahead and start with concurrent singles. And you can see here that we're going to run the test for S max iteration times, which is 5 in this case. And we're going to print out each iteration. What we then do is we're going to go ahead and do 2 things in parallel. So we're going to go ahead and find the best price from London to New York City. And we're going to run that in the common fork join pool using compose. And so this call, this from callable, will run this computation in the common fork join pool in some worker thread. And then in parallel to that, we're going to go ahead and have another call running in the background concurrently. And this is going to look up what the exchange rate is for dollars to pounds. And so this, again, is a from callable. We're going to run it in the common fork join pool, except this time we're going to put a timeout. And what this basically says is, if we go and make a request to the exchange rate microservice, which we're just going to emulate here, but which could be actually a microservice running on another server somewhere, if that computation runs for more than 2 seconds without returning a result, then we're just going to return the default rate. So we say, after 2 seconds, if we haven't got a result, give this as the result. So those are the 2 singles. Then what we're going to do is we're going to zip them. Remember what zip does? Zip is kind of like then combine with completable futures. And so it's going to say basically, wait for the price single to finish, wait for the rate single to finish, and then convert them. And we'll see convert does sort of an obvious thing. Convert goes ahead and multiplies the price by the rate. So that just gives you the conversion, the price conversion based on the exchange rate. In this case, we do something else interesting. We are going to put a timeout of 3 seconds. And what this says is, if this convert method is not called within 3 seconds, in other words, if it takes more than 3 seconds for all these things to finish, for both of these things to finish, then go ahead and throw a timeout exception. And we'll see how the exceptions are handled here. So we're going to use blocking subscribe, which will obviously wait until all the asynchronous processing is done. If all goes well and there's no exception, it just prints out the price in pounds. However, if there is an exception, in other words, if a timeout occurs, then we say what the exception was. And we're going to do this basically 5 times. So if we go ahead and run the program, you'll see what this does. It'll start out and it'll go through the iterations from basically 5 times from 0 to 4. And you'll see, depending on what the random numbers are generating, and we'll look at that in a second, where those come from, we get different results. So in this particular case, it looks like there are no exceptions thrown in the concurrent singles. But if you take a look at the parallel Flowables, which we'll look at in a second, you can see that there were exceptions thrown. Timeouts did occur. So if there's no exceptions thrown at all, then every time we go through here, it'll tell us basically the rate comparisons and so on. And this is kind of interesting. You can see actually there was an exception thrown. We just didn't catch it. We caught it and handled it. And I'll talk about that in a second. So remember what happens if an exception is thrown is it gives the default rate. So here's the default rate result. So that meant an exception timed out, or an exception was thrown because the rate microservice call was deferred. So it gives us back this price. However, if an exception is not thrown, if we get in contact with the microservice that does the exchange rate, then the exchange rate is not 1-to-1. And we'll take a look and see how that worked. So that gives us a different number. So let's go back over here real quick, and we'll take a look at a few more pieces, and you see where those exceptions are coming from. So here's the find best price method. You can see that find best price is emulating a microservice or simulating a microservice. It delays for some random amount of time, which could be longer than the delay. And if it, however, after it finishes, it goes ahead and returns a constant. That's, again, simulating what the microservice would have done if we'd set it up to be a client server. And then down here, we have query exchange rate for, and that does the same sort of thing. It waits for a random delay, and then it returns the exchange rate, which I've hard coded here to be 1.2. So when you see the higher number, that means that the microservice didn't time out. When you see the lower number, it means it did time out, and we took the default rate. So if you go back up here and you look at the code for this, you can see what we do. If the exchange service call times out, we don't propagate the exception, we just return the default rate, which in this case is 1. However, if the whole thing takes longer than 3 seconds, which is usually because the price lookup was delayed more than the timeout, then an actual timeout exception is thrown, and we're going to handle that here. So if you go back and look at the output, you can see when you see the 1065.6 number, that's when things did not time out. When you see the 888 result, that means that a timeout occurred looking up the rate service, and therefore we gave the default rate. That's just kind of giving you an understanding of what the results look like. Let's go take a look at parallel flowables. Same basic behavior. We're going to go ahead and look up the price from London to New York. We're going to go look up the exchange rate. Those things are going to run in parallel, except this time we're going to use a parallel flowable instead of using the subscribe on mechanism we talked about before. So here what we do is in the price flowable, we use the just method to get ourselves the mapping from London to New York. We just emit a string, and then we run in parallel using the common fork join pool, and this find best price call will take place in a thread from the common fork join pool. When that computation is done, we convert this back to a sequential. Same down here, we go ahead and emit the string that's going to look up the exchange rate. We go ahead and say run this thing in parallel, and then in parallel, we'll query for the exchange rate. And when that's done, we convert back to a sequential. And here we have the timeout. So if it takes longer than 2 seconds, we're going to take the default rate. And then down here, things are pretty much the same as before, except we're using a flowable now as opposed to a single. So we use flowable zip, which again, we'll wait for everything to finish. If that whole thing takes more than 3 seconds, we'll get an exception. If an exception occurs, we take this path through blocking subscribe. If everything goes according to plan, we take the other path through blocking subscribe, and we print the price out. So if you go look at the results here, you can see that when we ran the parallel flowables, there were some exceptions that occurred. So first of all, you can tell that an exception occurred here looking up the rate, the exchange rate, as we get back the default, whereas this one used the 1.2, this uses the 1.0. And then you can also see for this iteration, the timeout occurred, which meant that the whole thing took longer than 3 seconds because, of course, we're putting random delays in there. So in that particular case, an exception is thrown, and we go through that path of the blocking subscribe method to handle exceptions. So that's basically showing you how to handle timeouts for various parts of RxJava. A couple things to note here. First of all, it's probably overkill to use parallel flowables for this very simple example. You'd really want to use parallel flowables if you're doing something more than just calling one method in the background. The way we do it up here is arguably more simple, more concise, probably honestly more efficient as well, just using the common pool for singles in the compose operation. But other than that, the basic logic is the same. Once again, you can see there's a little bit of extra work required to handle this code with RxJava compared to doing it with Java completable futures. The Java completable future version of all this stuff is just more concise because, of course, it's not trying to, it doesn't have to handle all these other syntactic issues about running things in the background. So we'll take a look at that version in just a second.